Today we'll also be looking at velocity time graph, which describes acceleration. Velocity time graph means velocity is plotted on the vertical axis and time is plotted on the x or horizontal axis. So there's a problem here that we want to solve. A particle is moving on an axis or x from the time t equal to 0 with time t equal to 32 seconds. The particle is traveling with a constant velocity of 15 meters per second. The particle then decelerated from 15 meters per second to rest in t seconds. First question A. Sketch a velocity time graph to illustrate the motion of the particle. The total distance traveled by the particle is 570 meters. B. Find the value of t. So let's look at this problem. This is V in meters per second and t in seconds. So assuming this as 0, so they said a particle travel or moving on an OX axis this way from time t equal to 0 to time t equal to 32 seconds. And they said the particle is traveling with a constant velocity. This is 15 meters per second, or 15, since we have meters per second there. It's 15. And the time here is 32 seconds. We travel with a constant velocity of this. The particle then decelerated from 15 meters per second to rest, decelerated, it decreased to rest in t seconds, assuming this is t in seconds. So sketch the velocity time graph, which is this, to illustrate the motion of the particle. And the total distance traveled by the particle is 570 meters. We have done the first part, which is A. We have sketched the velocity time graph. Then the B part, find the value of t. Find the value of t. We know this is the shape of a trapezium. So the total distance covered, S, is equal to 570 meters. So to get the t, the value of t here, it means we have to state the formula of a trapezium, which will help us to calculate the total distance. So total distance in this regards becomes half a plus b times height. Now this is a and this is b. Distance from here to here. And then this is our height. So we can say that S is equal to half. Our A is 32. Distance from here to here is 32. What of B? If from here to here is 32, and from here to here is T, so the distance from This end to this end will be 32 plus t. Remember, the distance from here to here is t. From here to here is 32. So total distance from this point to this point will be 32 plus t. So that will be 32 plus t times the height is 15. So if you add up this, we can see that s is equal to 64, s equal to half, 64, that is 32 plus 32 plus t multiplied by 15. So we can write this as s equal to 15 over 2 into 64 plus t. So what do? Our s is 570. So we can write this as 570 equal to 15 over 2 to 64 plus t. So how do we make? If you cross multiply, we'll have 570 times 2 equal to 15 into 64 plus t. So what do? We now try to make t the subject. By doing that, we can write this as 64 plus t equal to 570 times 2 divided by 15. Is that right? So what do? We can try to reduce this. 5 into 15 is 3. 5 into 5, 1. 5 into 70 is 14. So we can write this as 64 plus t is equal to 114 times 2 all over 3. And 114 times 2, what do we get? Is 228. We have 228. 64 plus t is equal to 228 all over 3. So 3 into 21 is 7. Is it not? You remain 1. That is 3 into 18 is 6. So we can write this as 64 plus t equal to 76. So by the time you take this to the other side, it becomes minus. And t will be equal to 76 minus 64. Is that right? So by the time you take the difference here, t now will be equal to 12 seconds. So it means that the time it took the car to decelerate to this point is 12 seconds. So with this, we can now calculate the total time here. Is that right? From this point to this point. It's not part of the question, but we can do it. We can do it. Total time, therefore, total time will be equal to 32 plus 12. Is that right? Which is equal to 44 seconds. The total time from this point to this point becomes 44 seconds.